Hello everyone, a very good morning, afternoon, and evening to all. Dear authors and invited guests, welcome to Technical Session 4D. My name is Anisha, and this session would be moderated by me on behalf of Global Knowledge Research Foundation and GR Scholastic LLP. It is my great pleasure to welcome you all to the 9th World Conference on Smart Trends in Systems, Security, and Sustainability, WS4 2025, London, UK. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in London, UK, and the virtual event is being held through Zoom today and tomorrow, that is 20th and 21st of August 2025. I hope you all will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 6 presentations, and each presenter will be given 12 minutes for the presentation and 3 minutes for question and answers. So on 10 minutes, I'll be raising a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing of the session. And if you have any update or query, you can write it to me in the chat box. So before we start with the session, I'd like to introduce you all to the chair for this session. We have Ms. Shreya Ji Tendulkar. Ms. Shreya Ji Tendulkar, associated with Syracuse University, New York, USA, specializes in machine learning, artificial intelligence, large language models, and ethical privacy technology. She works in product development at Berkshire Hathaway Inclusion and is a member of the Forbes Technology Council, contributing to advancements at the intersection of technology, ethics, and innovation. I welcome you to the session now. Would you like to give an opening remarks to all the participants?
Thank you, Anisha. That was a great introduction. It's truly an honor to be here today as the session chair for the 9th World S4 2025. And to give you a brief introduction about myself, as Anisha mentioned, I'm Shreya, working as a software engineering leader in the United States. And over the past several years, my professional journey has allowed me to contribute across various domains, right from finance, insurance, health tech, which have led to the development of AI platforms, API integrations, and even cloud-based solutions. And these have also led to global product deployments at Google, Berkshire, and even Dexcom. And alongside this, I've also been into research with IEEE and Springer publications targeting LLMs, ethical AI, and energy sustainability as well. And what excites me most about this conference is the focus on collaboration, sustainability, and security. And I'm sure our presenters of today's session have a great dedication towards research and creativity. And I'm truly looking forward to your meaningful presentations and engaging discussions with you. Thank you.
Thank you so much for your remarks. Looking forward to your valuable contribution in the session as well. And we have another session chair for the session, Dr. Tanupriya Chaudhary. He is a professor at the University of Petroleum and Energy Studies, UPES, Dehradun, Uttarakhand, India, with over 15 years of academic and research experience. He has authored numerous publications in high-impact journals and conferences. His research interests include AI/ML applications, specialized algorithms, geoinformatics, AI in healthcare, brain computing, cloud computing, and verifiable computing. I welcome you to the session, sir.
Thank you, ma'am. Please go ahead. Thank you.
Okay. So with that, we'll be moving forward to the first presenter of the session. We have Narmeen Marji with the paper title Between Critique and Creation, Participatory Speculative Design for Urban Futures. Do we have Narmeen here in the session?
Yes, I'm here.
Okay. So you can start with your presentation.
All right, let me start by sharing my screen. And I believe you see it now. All is good.
Yes, it's
All right.
visible.
So, nice to be here. I'm going to present my work titled Between Critique and Creation. It's participatory speculative design for urban futures. So I'm Narmeen Marji. My background is actually in architecture, urban planning and design. I'm an XR developer, currently an XR specialist at Helsinki XR Center, and I focus mostly on designing virtual space in urban contexts from a technological background, also human-computer interaction. Let me start by stating the context and the motivation of this research. So why do we need new approaches to urban futures? As we know, cities are facing rapid challenges and it is not getting any better. We're talking from environmental challenges to rapid urbanization, technological pressures, environmental issues. And this is continuously rising the complexity and the pressures on urban infrastructures to handle this. But also, we are facing this problem, this crisis of imagination. So people can no longer imagine easily utopian futures or futures to look forward to. There's always this fear and anxiety of what the future holds. So when we tackle participatory speculative design, it is a framework to get these people together, different stakeholders, to collectively imagine a better future, something that addresses complex challenges. And as all of you know, I will be preaching to the choir that the rapid technology development, and especially in artificial intelligence, it's raising lots of concerns, ethical concerns, where is my data going, and so forth. So in this research objective, we are aiming to conceptualize futures through participation. We would identify recurring themes, concerns, and possibilities across different visions, and then we assess how it complements conventional urban planning and technological design. So it takes images and imaginations from diverse backgrounds of people to engage them in complex challenges to defy or find better ways than traditional problem-solving methods. So it's by nature, the methodology is a research through design approach. We conducted 2 full-day workshops in 2 cities in Finland, so Tampere and Helsinki, the capital and the second largest city in Finland. The analysis was done through qualitative content analysis, and we used a typology of fantastical cities to actually classify and systematically analyze the visions that were created. The workshop structure was an introduction. We walked through the city, observation. There was brainstorming, creative materialization of the concepts, building prototypes, and then group presentations and discussions, and all those were recorded. So we brought the people together, focusing on what-if scenarios. So things that tackle issues like artificial intelligence, surveillance, ethical concerns, climate change, emerging technologies, and see how people envision the future based on those. So first workshop was in Tampere, as I said. It had 12 academic experts in architecture, urban planning, interaction design, game studies, and social sciences. Tackled 4 zones. Then we have the Helsinki workshop, 12 participants from diverse backgrounds. We had also architects, urban planners, cultural managers, entrepreneurs, and members of the public who were interested in this. And you would see that the scenarios that they developed were quite different. So they range from AI religious surveillance systems that are omnipresent throughout the city to governance by non-human forms, so whether AI governance or animal governance, submerged historical city centers tackling water issues, teleportation even based on social stratification. But from those, how do we understand these visions? We conducted the qualitative analysis. We used the system. We had the systematic use of the typology of fantastical cities. So this kind of works as a classification system for the visions that are created. So you bring something that is quite fictional into reality and understand the implications of this on technology and human-computer interaction. We triangulated the data sources that we collected. So we had audio, video recordings, physical artifacts, photographs, city sheets, field notes. And then we did a cross-case analysis, so between each scenario developed to identify the themes and the patterns across the workshops. For example, I would go through these quickly, but the critical question, for example, from the first vision of emotion harvesting, this one talks about bodily data extraction, surveillance, and commodification. And the question would be, well, who benefits from the extraction of this emotional data? Again, the second vision, how do technological solutions reproduce inequality? So climate adaptation islands. Then we had visions on AI-governed trees, where verticality and people withdraw from the surface of the earth. So what happens when human-centered governance is replaced? Memory machines, who controls the narrative of urban memory? So this all talks about the technologies and how they are becoming more invasive, and how do we gain agency and preserve human autonomy in these scenarios. So we were exploring tensions between technological control, identity. So you would see different varied reasons, but visions, but each vision has complex power dynamics and understanding the consequences and even unintended consequences. So this shows how the participants they were able to engage with the possibilities and risks of future urban technologies. So the main theme that emerged, four main themes, we had governance transformation. So we are looking now at beyond human-centered control, hybrid or algorithmic governance. So we're talking about AI or non-human actors actually having a say in decision making. Imagine futures where cities are co-governed, sometimes by even animals or distributed intelligence. The second theme was body technology relationships. So from bodily enhancement to extraction and surveillance. Workshops, they include emotion harvesting system, teleportation technology with embodied risk, emergent forms of bodily resistance to technological control. So these are concerns and actually anxieties that people currently have. Environmental adaptation strategies was a third theme. So there were creative and smart responses to climate change, including going above the ground and even underwater. Hybrid adaptation, managed displacement. So that moved beyond technical fixes to deeper social and ecological reorganization. And this is something we face in the tech industry, is producing tech for the sake of tech and leaving the people and societies out of it, which is something that we should pay better attention to in the future. And the fourth theme is social stratification persistence. So inequalities, if they exist in today's world, the technology would either intensify or even they would not, it would not be a permanent fix to it. So there are issues that technologies cannot completely solve. So they either reproduce or exacerbate social divides with new forms of privilege emerging around the access and the adaptation of the resources. Why this works matter for HCI? So beyond user-centered design, we embrace hybrid agency, multi-species futures, and ethical ambiguity in technical systems. Because when you are designing in such a rapid space and rapid development, and you have such uncertain futures, you need to engage people and you need to engage speculative visions and see what you can derive, what kind of information you can get from that. Inform responsible design, so urban governance interfaces, adaptive environmental sensing, emotional-driven interaction paradigms, and then you challenge the technical community to engage with uncertainty, critical perspective, technological ambivalence, and system design. And probably one of the most important ones is to bridge the disciplinary divides between HCI, the tech, urban planning, and public participation, basically, for shaping tomorrow. So what we learned from this, the findings, basically, other than the four themes, is that we need to focus on responsible system design, so transparent algorithms with built-in contestability, systems that enable users to question and modify the decisions, so you know where the data goes, it's not a black box anymore. Then hybrid agency model, we're moving beyond user-centered paradigm, so we have distributed decision system, we have somostatic computing, so urban interfaces no longer deal with humans as just the input. We provide bodily experiences and emotions. So the systems map and respond to the emotional states. And of course, the ethical infrastructure. So there's bias detection in urban governance system because this controls the lives of so many people. And user configurability privacy settings, if you are in a hybrid or public space, you can control. For urban planning, so this demonstrates the value of multi-species or hybrid governance, imagine beyond technical solutions to social organization, and reveals concerns about inequality, environmental change, and emotional experiences. For the future, we know that now participatory speculative design is a very powerful tool for broadening urban futures thinking, but not only that, but also for including technical and technological developments into the equation. Next steps is cross-cultural replication, translation into practice, what this actually means. And we know that it complements planning and design approaches in both technology, urban planning, and design. But yeah, this is the end of my 10 minutes, and thank you.
Is the review paper you have made?
Sorry?
Is it the review paper?
No, it's a, what is a review paper? It's a full paper. It's a research, and we
Okay.
conducted workshops and we did the analysis and then we published it and we got the
Fine.
findings. Yes.
It's nice work. Thank you. No
Thank
questions.
you. Okay.
Great presentation. I had a quick question. So how did you ensure the diversity and participant perspective during the speculative design workshops in Tampere and Helsinki?
Yes. So in Tampere, mainly the first workshop was targeting academic people, like people from master studies, PhDs, and so forth, because we wanted the expert view. Because people who have that kind of knowledge, they perceive things differently and they have a more critical, let's say, vision towards things. And then the Helsinki workshop, because it's the capital, it has more people. We promoted the workshop highly across all of our channels, social media. We targeted literally everyone who's interested in urban futures. But then again, it is one of the limitations that I must say that this is still within a Finnish context. It's a Western vision. So this is one of the things that we need to work on because it is a good tool, but in order to actually have a good, or I mean, let's say a shared imagined future, we need to include global perspectives and have Eastern countries and Eastern perspective also participate. So this is something that we should work on definitely.
Makes sense. Thank you.
Thank you.
Thank you for the presentation. Moving on to the next presenter, we have Alberto with the paper titled Cloud Computing and IoT for Data Collection and Analysis, a case study in poultry farms. Do we have Alberto in the session?
Hello, good morning. I'm here.
Yes. You can start present with your presentation.
Okay. Do you see my screen, please? Confirm me.
Yes, it's visible.
Okay, well, thank you for your time. It's really a pleasure to be here. In this conference, I will talk about my investigation, cloud computing and IoT for data collection and analysis, a case of a study in poultry farms. And I'm going to start for explain you where I am. I'm from El Salvador, which is located in Central America, and next to Guatemala and Honduras. We are a tropical country. We have a lot of beauty to offer you. So if you want to come, please just come. About the research, I have to mention that this research was carried out with two universities. The first one is Universidad Makerere. The other one is Universidad Tecnológica. It was three faculties working on this, the Faculty of Business Science and the Faculty of Veterinary from USAM, and the research director of UTEC. About the agenda of this presentation, I will talk first about the introduction, then the system architecture, then the study design, then the discussion, and at the last, the conclusion. The introduction, as we know, sustainability transition are shifting the key socio-technical systems. So energy, water, mobility, and food are main topic about this. Poultry farming is the main protein source in El Salvador. And this is why this research made very relevant. Okay, the environment factor are critical, influence broiler growth and welfare. So in my country, the traditional way to monitor the parameters are made by humans. There is no technology available for the little producer. And this is why we are talking about this innovation here in my country. We propose a solution to take 7 environment parameters such as ammonia, nitrogen dioxide, carbon dioxide, and carbon monoxide, light intensity, temperature, and humidity. About this, as a country and a region, we need for local and continuous data. We don't have so much data in my country and my neighbors, and we need to have more data, and that's why we are taking this data from the broiler house to improve the chicken health and growth. The absence of pre-available local datasets limit effective and target management strategies. Affordable IoT and cloud-based solution can transform poultry management and limit resource sharing. The objective of this project is develop an economic and scalable system using cloud computing and IoT for environment monitoring. The system architecture, well, we propose this architecture. So we have the poultry house in which we are going to take these parameters, temperature, gases, humidity, and light intensity. So the IoT platform will send this data using the Wi-Fi signal to the cloud for do an analysis and dashboard after this, and at the last step, do like a storage, like a backup in the cloud. This was the IoT sensor you can see on the left. And we use the ESP32S3 microcontroller and I2C sensors to take these parameters. About the cloud architecture, we are using all free-tier plans. That's important because the little producer can spend more money to take this data, okay? So we use the free trial plans, and the data transmission will be Wi-Fi, and we collect the data storage at the first step in Google Sheet. Then we organize this data and send it to Power BI, and the data was analyzed and processed and visualized using Power BI, okay, with a secure backup in Azure Blob storage. This is how the data was looking in a Google Sheet. And this is where we work this data and make this graph in Power BI, okay, to know the summary and the average of the parameters. And this is how we visualize the data in Power BI. And the study design, this was made in Zapotitan, is located where is located the veterinary field managed by USAM, and it's about 450 meters above sea level. The duration of the project was 42 days from June to August, and we were on a winter season, a lot of rain. And about the chicken, we use the Arbor chickens. There is a breed focused on the meat production. The growling house were net protected, as you can see in the picture. Rice full bedding gradually increased from 4 to 80 square meter. Sensor placement were at 0.3 meters above ground, the same weight as the chicken, and data were collected at 5-minute intervals. The data collection and processing. Data transmitted stably through some interruption during heavy rain, cover data for compatibility with Power BI dashboard, and monitor parameters were weekly and daily summaries. As a key result, the system successfully collect and visualize environment data. A further veterinary research could examine the correlation between the environment parameters and broiler weight, health, and mortality. A decrease in NH3 was observed after introducing rice host bending. Discussion and implication, the cloud computing and IoT system proved feasible and cost-effective. The generation of local data contributes to the creation of literature specific to the country and open up the possibility of developing more in-depth studies of this topic, and the system scalability could extend to other sectors like swine farming. Conclusion. Demonstrate the successful implementation of a low-cost and IoT and cloud computer system, provide new local data and environment parameters affecting broiler growth, show the potential for data-driven decision-making and enhance animal welfare and farm productivity. So cloud computing and IoT represent a significant breakthrough in intelligent management of poultry farming. What are we doing right now? We are working in automated notification and environment parameters in poultry farm using cloud computing and IoT, and automation of farms inside poultry house for efficient control of environment parameters. This is like the second step of the first of this investigation. And as a possible future research, it could be considered analyzing the response of this chicken breed to local climate to identify the best adapter and replicate this research in different countries and expand it to the other agricultural sectors such as wine farming. This is all for me, and if you have any question, please let me know. I have put it here in my sheet, so if you want to scan it, you can do it too.
Great presentation. One question, which environmental factor until now had the strongest observed effect on broiler growth in your 42-day study?
Good question. Well, as we work with a veterinary, I was talking with him and he told me that humanity in any tree that was like the more affect to the broiler growth.
Okay, and what challenges did you encounter in sensor calibration?
Oh, first of all, it's not about calibration, it's more about Wi-Fi signal. So we did the project in a place that has no a good signal from internet. So we have to make some change providers and other things to have the correct signal that we need.
All right.
Professor, what are the total sensors you have used? Which sensors actually you have used?
Yes, let me show you. This one.
Okay, and may I know the total cost of the system?
It's about 300 bucks, USA dollar.
Okay. Fine.
Oh,
It's a nice
all
one.
the, yeah, all the solution is less than $1,000.
Okay. Fine. Very good work. Thank you.
Okay, you're welcome.
Thanks a lot for the presentation. Now, we'll be moving forward to the next presentation. We have George with the paper titled Machine Learning Simulation Algorithms for Energy Consumption in High Performance Computing Processor. Do we have George in the session?
Yes, here I am. Thanks.
Okay. Yeah, you can start your presentation.
Okay. Well, thank you for your time. We are part of a team at the University of Guadalajara in Mexico, and we work with the National Network of Supercomputing here in Mexico. And for us, it's a pleasure to be here at the conference. And our work is focused in how to make algorithms that can produce a model that can imagine the energy consumption of high performance computing processors. And one of the techniques that we are presenting here is undervolting, and how undervolting can optimize the energy consumption of high performance computing. Next, please. We are part of, we work in the Data Analysis and Supercomputing Center of the University of Guadalajara. And this is a model that presumes the supercomputer that's named Leo Atrox. And we work with the CISESE, that is a research center in the southern of Mexico. And well, first, the first part of the research will be with my co-author, Ricardo.
Good evening. My name is Ricardo, and together with my colleagues, we are thrilled to present this work at the World Expo Conference. As Doctor said, our work is titled Machine Learning Simulation Algorithms for Energy Consumption in High Performance Computing Processors. The main focus is to address a major problem that every high-performance computer centers faces today: excessive energy consumption. Our proposal combines machine learning techniques with undervolting to reduce power usage while maintaining an acceptable level of performance. As you can see here, we have our motivation to make the article. High-performance computing centers consume massive amounts of electrical energy, not only because of the number of processors, but also due to cooling systems. This results in very high operational cost and a strong environmental impact through carbon emissions. The current trend in processor design is to increase force and clock frequency to maximize performance. However, this approach increases energy even further. The challenge we address is to find the balance, keeping high performance while controlling power consumption. Next, we have our research objectives. Our research had three main objectives. The number one was develop a machine learning model using linear regression to predict energy consumption in HPC systems. The number two was to apply the undervolting technique, which can reduce the operation voltage of the processor to limit its power consumption. The number three is to demonstrate that it's possible to improve energy efficiency without significantly affecting performance. In short, this is not only about saving energy, but doing it smartly without reducing computing capacity. Next, we have our methodology overview. Our methodology had several stages. First, we generated simulated CPU energy consumption data to train an initial model. Then, we applied linear regression and evaluated accuracy using metrics such as mean square error, that, as you can see here, is marked as MSE, and the coefficient of determination, that it's marked as R squared. Later, we extended the dataset with real measurements from the Leo Atrox supercomputer at the University of Guadalajara. Finally, we applied the undervolting technique on an Intel Xeon processors to validate whether the predicted savings were achievable in practice. And how did we collect data? To collect the real data, we use the Slurm Resource Manager, that it's a standard in the industry, which provides detailed monitoring of the CPU usage, voltages, and node-specific metrics in the cluster. These real-world measurements complemented our simulated dataset, allowing us to train a much more reliable and representative model of actual HPC consumption. And why do we choose linear regression? We chose linear regression because it has several advantages. It is simple and easy to interpret, even by non-experts such as energy managers. It has a low computational cost, meaning it can run in an HPC environment without adding overhead. And finally, it provides a reliable baseline for moving on to more complex methods, such as neural networks or ensemble models. Now, one of my colleagues will continue with the presentation for a deeper explanation. Her name is Scarlett Berenice.
Thank you. I'm gonna start with explaining the undervolting. Can we see the next, please? Okay. Well, as we can see, undervolting is the process of reducing the over operating voltage of a processor or electronic component below its default level. Well, means reducing the processor voltage and frequency. Our goal is to maintain a good performance while we are lowering the energy usage. Well, we reduce the CPU operating voltage by less 50 millivolts to stabilize performance while lowering the power. And we use that equation and to generate the dummy data, enriching our data set and improving the model predictions. And well, it also extends the lifespan of components and reduce the need of cooling the HPC. And next, please. Well, this is our machine learning model. We can see all the specifications in here. And well, we use a linear regression model trained with historical energy consumption data. And this data set was collected from the Leo Atrox, as we said, in the University of Guadalajara. And this model allows us to simulate energy consumption patterns and estimate savings when we are applying the undervolting model. Next, please. Well, our results. As we can see, we achieve a 6% of savings in the CPU consumptions and up to 10% in cooling system. Well, the model provide reliable predictions and closing to matching real measurements. And this confirms that undervolting is effective and scalable for a large infrastructures as the Leo Atrox. And well, we have to be good with the planet, so this is hence in the carbon footprint. Next, please. We have our benefits and impact. We, of course, reduce the operational cost. Lower CPU voltage directly reduces draw, and we are cutting energy expenses. And we also, as we said, we lower the carbon footprint by using less energy. Well, our undervolting contributes to sustainable high-performance computing practices. And adaptive, energy-aware scheduling possible. Well, that would be easier too. And of course, longer hardware lifespan. As we said in the undervolting, this extends the lifespan components and reduce the need of cooling. And well, this prolongs and lowers the maintenance frequency. Next, please. Well, in the conclusions, undervolting supported by machine learning, we see that it's viable and practical in a practical solution, and it balances performance, efficiency, and sustainability too. And this research paves the way for smarter and greener supercomputer infrastructures and also in the architecture of the supercomputing structures. Well, our future work is expand to additional ML machine learning models, neutral networks, and deep learning, and integrate energy-aware policies into a job schedules like SLARM. Well, that would be the ideal. And well, I think that would be it, right? We don't have another slide. And well, my colleagues and I will be happy to answer your questions. And thank you, that will be it.
Ma'am,
Great
may I know
presentation.
how the accuracy is justified by using
Yes,
ML algorithm?
yes, we have in the results. It is justified. We have the graphics, I think, for justify this.
Is there also any statistical method?
Yes, I think it is, yes.
No, I was asking about any statistical methods also you have used.
Oh, okay, statistical methods.
Yes, we have professor. Thanks. The statistical method that we say that we're a linear regression, and we use an optimization system that has the Leo Atrox, the computer and the processor to make that projection that we have in the next slide. and it's just a projection of the consumption, and that we have the accuracy that is compared with the real data, and the real data is kind of 5% of 10% of dispersion that that the real data have with this projection.
Okay, fine.
Could your approach be generalized to other HPC systems beyond Leo Atrox, or is it like system specific?
Yes, the real mean of this research is to apply in another processors and another system. That's now we're working with the National Network of Supercomputing here in Mexico, and we're trying to work with some computers in the Latin America computing systems. To make, as Professor says, this is only with one processor, but the idea is to use in another processor, another systems, and now we're working on that, using in another computers.
All right. Thank you. Great presentation, team.
Thank you for the presentation. Moving on to the next presenter. We have Reshma Unikrishnan with the paper titled Parameter Efficient Turned Long Former for Diagnostic Code Classification Based on Unstructured Clinical Reports. Reshma, are you present in the session?
Yeah, I'm present.
Yes. You can start your presentation.
Okay, I hope the screen is visible.
No, you have not shared the screen yet. Now it's visible.
Okay. Good afternoon, everyone. My name is Reshma Unikrishnan, and I am a research scholar from the Department of Information Technology in NIT Karnataka, India. And today, I'm here to present one of my research topics on a parameter efficient tuned long former for diagnostic code classification based on unstructured clinical reports. Sorry. Yeah. So this is the outline. I'll give a quick overview, and then what is the problem statement, what are the observed research gaps, and based on that, what is the proposed approach we have come up with, and the results, conclusion, and future work. So giving a picture about this ICD coding, it is nothing but International Classification of Disease Codes. So why do they use this? So normally in a healthcare setting, in hospital, when we enter a hospital, they digitize all our records and keep it. So when we get discharged, or when we are there for a long time with some disease or something, and then when we get discharged, for claiming our insurance, for administration purposes and all, medical coders sit and code these our own electronic health records, or these digitized health documents, and they code like for diagnosis codes, procedure codes. They have several codes, so they code in such a way, and they keep it in a structured format. So how this is usually done is, all these health records are usually written in any form, like be it in one clinician in one way, nursing notes in the other way, radiology reports in the other way. So each thing is different, discharge summaries the other way. So, and also it varies from clinician to clinician. So in that, what these medical coders who are trained to do that, they sit and read that and look out for terms that actually map, and based on that they code that each of these documents. So this is how things are happening. And commonly, if you see this this task in the research domain is normally addressed using this particular data, that is MIMIC. MIMIC is nothing but Medical Information Mart for Intensive Care, and we are in the 4th version now. If you see, only in that alone, they are releasing around, so there are 2 different codes, ICD 9 and 10. In ICD 9 alone, there are unique codes of 11,600 and I mean 11,000 codes and odd codes, and here 31,000 codes are there. So imagine sitting and reading and assigning these codes is really trivial. So practically, if there are some automation or if you can aid a support for them, that will be more efficient. So that is the aim of the study. And the problem statement is mainly focusing on handling these lengthy documents. And normally one particular document, that is a patient's document, will not have only one code. It will have several codes. So it is a multi-label document classification problem. And we know we are in the era of large language models or LLMs, what we tell. We are all using ChatGPT and all this. But before this, what was it? It was transformer based. From there, it's extended and it has come here. So here we have leveraged the transformer models. And on top of it, when we leverage it, how can we use it in an optimized way to do this? Because it's huge. We can't sit and ask it to train it and wait for it. So in an optimized way, how can you use those transformer models and also make it specific for this particular domain? So how do we do that? So that is a problem statement. Normally, how this particular task is approached is the data representation is focused on CNN and LSTM based architectures or these deep learning architectures, and also transformer based models have been adopted. What happens is in this data representation techniques is if you see these BERT based models, if you all are aware, I know most of you are aware of it, these transformer based models have a limitation of handling only 512 tokens. So there is a restriction in handling lengthy documents. So they go for decomposition, chunking, or averaging mechanisms. This is how they represent the data. And handling class imbalancing, they go for oversampling, resampling, and these kind of techniques, data augmentation, ensemble learning. So the research gap which we found is integration of domain specific. Here we have used long former, which handles lengthy documents. So domain specific long former, here again specific to that we have used, with parameter efficient tuning or the optimization techniques which we have come up with for tackling these length and class imbalance challenges remains unexplored. So in particular, in this data study, we have made use of this Mimic 4 only. And the labels have been released because this has been done for years. Like from 2018, a standard data set has been released. And on top of that, because data preparation is one thing, and then we benchmark, it comes like that. So for Mimic 4, a similar pattern like how Mimic 3, the older one version, in that way, the labels have been released by one of the study, and we have adopted that. So the statistics of the discharge summaries is what we are focusing on. And this is the statistics. You can see it's huge, like total ICD codes and the unique ones are here. And getting into how we designed this parameter efficient tuned long former or PET former, which we have told. First, it was about selecting the foundation model itself. So lengthy text sequence handling using long former, specifically moving into what was tuned on that, that is incorporating domain knowledge. We went into using clinical long former because it was already tuned on Mimic 3, the former data set, keeping Roberta as the base. So Roberta itself is tuned on other documents. We all know that the common documents which are available in the internet. And on top of that, the domain knowledge is taken from Mimic 3. So when we already have a model, why don't we apply only optimization techniques and make use of the one that has to be retrained or tuned to your particular task instead of retraining all the layers in the transformer layer is our approach. And we have evaluated it using macro, micro, F1 and area under precision recall curve and ROC. So if you see, this is a overall framework. How it looks is when we input the discharge summaries, you can imagine this is a network and specifically focusing on transformer based models. And since Roberta is the underlying one, imagine there are 12 layers. So in this 12, instead of retraining all the 12, we are only focusing on the one that is data specific, or which is the one that we need to retrain for our particular data. So only there we make use of this parameter efficient tuning techniques like mix out, discriminative learning, fixed discriminative learning, group discriminative learning, and see what are the variations, like how we can tune it, optimize it, and take out with binary cross entropy loss, which is good at handling the class imbalance. And then we see only for top 50 classes in this ICD coding. So this is the overall framework. And if you see the word length variations in this discharge summaries, it is like 500 to 5000, talking about why we went for long former, because previously I had told that in BERT it is restricted to 512, and then they merge like average, and they do things like that 512 in order to handle the entire sentence. Here what we do is, since long former itself is handling 4096 tokens, we wanted to see whether that is a right approach, because getting into long former, how is it getting like where is our data fitting inside? So it is between 500 and 5000. So we are not going into any averaging or decomposition techniques by missing out information. Rather, we are just applying it on top, and on top of it, instead of retraining everything, only the optimized or the data specific layers are retrained using mix out and discriminative learning. So we'll see the effect of mix out here. So mix out, if you see in a general picture, it is like dropout is something that like we simply randomly throw away the weights. So mix out is something that you don't throw away the weights, but you retain the learned weights already in that model, and only the new ones have been relearned. So mix out doesn't miss information. So how do we know the effect of using this is actually the training and validation loss difference. So normally if your model is performing well, your training and validation loss shouldn't be of big difference. So the difference between training and validation loss is plotted here. If you see these red lines, no, as the number of epochs increase, this loss is getting decreased. But whereas without mix out, if you see, there is a lot of variation. So mix out has some effect in our study. And we have actually benchmarked our work, and these are the existing works which we have compared with, and specifically Mimic 4. Yeah, so to conclude, this is a parameter efficient tuned long former model. And this is actually a preliminary work because we have taken only top 50 codes from the Mimic 4 data. So as part of the future study, we'll be taking all the codes, and also we've also observed that this particular ICD coding, practically when it is done, like most of the works tell it is very hierarchical in nature, and then you'll have to see one code is dependent on the other in that way, like alphabets and numbers are all coded together. But it is actually how when we went inside and met people who are coding, they told that like some codes, they assume that alphabet, say A 2.1 something, if it is there for one particular disease, say cancer, they tell that that particular A something is not present for neonatal patients or babies. So it is not the case. So alphabetical and numerical indexing should be considered together rather than going only for the numerical indexing, and especially taking the code descriptions and the meanings of that would actually make the system learn better than simply blindly giving the code. So that is already going on, that work. So that will be our future work. Thank you.
Great presentation, Reshma. Very relevant. So could pet former be adapted to multimodal clinical notes?
Yeah, that work is also, we have sent it as a journal. It's under review. We have already done that. Not for diagnostic code classification. We have done it for length of stay, mortality prediction, and CXR image disease prediction. So these three are the tasks which we have handled. Yeah, multimodal data is handled. So images, time series data, notes data, and structured tabular data. So this is also done. Yeah.
Okay,
so this
great.
is a small work. Yeah.
Okay, so how are you kind of handling the noisy and incomplete data in clinical notes?
Now, currently, for this particular study, data preparation side was given less focus here. Here, it was just adopted the way the authors had released the previous or the benchmarked data, how it was released. As such, we have adopted handling of abbreviations, handling of what is it? There are slangs like certain clinicians use and only they can understand. That is not handled as part of this. So that particular noise is still there. But only in this, we were focusing much on this particular adaptive learning or this parameter efficient tuned model. We have experimented with various data, like even this multimodal data also we have experimented with. So we wanted to see how this model will fit if the data is complicated in this way, and if it is in its raw format, how will it handle it? So as part of that only this experimentation came up. Yeah, so that
Got
is
it.
not handled. Yeah,
Got it. Perfect. Thanks.
thank you.
For the presentation. We'll be moving on to the next presenter now. We have Abdullah Sareh with the paper titled Search Algorithms and Large Spatial Data Using Analytical Digital Circle Definition and OpenMP Library.
Okay. Okay. It's okay now?
Okay, yeah. Yes.
Okay. Thank you. Thank you. Okay. Okay. So the topic, I can go now. Okay. Thank you very much. So the topic relative to propose the algorithm to realize the research in spatial data. And in this work, I think that I go to present introduction, method description, application analysis, and conclusion. What is spatial data? Spatial data is any type of data that directly or indirectly reference specific geographic areas, and that means that you have a reference related to geographic data, and also we can have more data to describe information in a specific position of the data. And sometimes we have spatial data most often numerical, and that describe a specific position. And we have many kind of modelization, rather image, vector, and real world. Okay, but in this work we are very oriented in raster image, which inside we can say pixel. That is very used in image processing, and the pixel will be in nowadays analyzed as the cluster that will be used to research information inside. This is some representation of spatial data, okay, from some toolbooks we use for that. And our problem, you know, that data in spatial data, there are many problems: data volume, data complexity, and a lack of resource. And a big challenge with geographic analysis that prevent companies from using the data effectively. And the step to analyze the spatial data as follow: your acquisition, transformation, data analysis, and data interpretation. But here we are focused on data analysis and data interpretation. The problem exactly is that to find the best seat, for example, the best pharmacy in a town, according to a specific areas, the nearest seat to with some condition based on the data in order to find information in a specific position. And that means that I have realized many research in digital geometry, and if we consider a raster image, we need here to use the concept related to digital geometry in GIS, because we want to combine spatial data, the concept, and also the concept in digital geometry, because spatial data can be represented by a rather image. For example, the first step or method is to use a regular grid that can be superimposed on the earth, and there are many models that exist in the sense in digital geometry. We have in Vacantesi in 2007, he proposed many models to of type of grid that can be used in 2 dimension, and you have also a quasi-affine transformation you can use to produce a grid. As you say that you have how to produce grid using a quasi-affine transformation, and when you superimpose this grid on the hair at a point sit here, you see that it is as a matrix. You say superimposition of the grids on point seat, and you see that the point seat on that represent information about, for example, pharmacy in specific areas. And you see that you can have this kind of representation. You see the matrix superposition of the matrix on the different position seat inside. And our contribution especially is how to use analytical digital Cyric definition. Eric Andres proposed analytical digital definition in discrete geometry, and how to use this definition to determine the nearest seat from a specific position. This is the question. I will say that you have a specific position here, and we need to determine the nearest seat from this specific position. And that means that the different seats are in the cluster represented by pixel, and we have to write algorithm in order to find according to a distance based on the analytical algorithm proposed by Eric Andres in order to find the different seats inside the cluster. So here we propose the algorithm to search spatial data. This is a sequential algorithm. It consider the definition of analytical circle proposed by Eric Andres exactly. Just you update that to apply in order to find seat. This is an algorithm very well known. You can see that in internet everywhere. But we want to integrate a year to apply that in JICE data. And we introduce in this algorithm OpenMP primitive in order to allow parallel research in order to accelerate to find information in the different clusters that correspond to the pixel here. And we have elaborated different algorithms in this sense. There are many kind of algorithms that has been proposed to share information in different seats in the cluster. And we have proposed different algorithms to find the seat, the reference of seat. But in this context, we need to propose. We have proposed two techniques to share information in the cluster. The first thing is to consider we represent a matrix in 3 dimensions for the research information in cluster. Or the second is to use 2 dimensions in order to find information. But we have to understand that the research here consider the growth fly, but doesn't take into account the path to go to the nearest seat. The length of the path is based on a road is not used. But it is interesting, you notice that obstacle can be occur in the road. But even we will consider a path direction to go to find the best seat. As implementation, for example, we can represent here in each cluster, you have different seats that in 3D dimension. And after, if you use, for example, a MongoDB, and we use this reference in here in order to research in the database. And the second method is to put in directly here the cluster reference in this matrix when you use a 2-dimension in order to find directly in the MongoDB database. So I think that we have realized here a proposition for research spaces that to find special seat. Design is established, but in perspective, we have to do comparison and improve your application in real context. So thank you very much. Thank you.
Thanks for the presentation. How does the analytical digital approach that you mentioned compare in efficiency and accuracy with the existing spatial indexing methods, maybe like R trees or quad trees?
I think that, for example, if you consider, you take, for example, Google, you can see Google, we can find algorithm which can use, for example, to represent a path with as a graph. This is a method that can be used, also an existing method that can be used to find a seat according to an initial position. So, but here we use analytical seek, but we want to at the end to compare this proposition to find based on analytical seek with the existing system, which is based on the graph, because they consider, for example, a path, a road, the distance the road. We use that every time when you use, for example, Google Map. So you one need to compare with that in order to find to see that the best solution. That is we plan to do in perspective.
All right, thanks.
Okay. No question again? Okay.
Thank you for the presentation.
Okay, thank you. Thank you very much. Thank you.
We'll be moving forward to the next presentation. Next up, we have Intan Pradita with the paper titled The Prior Corpus, a specialized collection of Indonesian authored ELT research articles. Do we have Intan here?
Yeah. Okay. Thank you for the opportunity given to me. My name is Intan Pradita, and this is our project with Dr. Devi Ambarwati Puspitasari, entitled The Prior Corpus, a specialized collection of Indonesian authored ELT research articles. So the rationale of this project is that we consider English as the most popular lingua franca, and it remains dominant in the global academic publishing. However, the non-native English-speaking authors are more numerous than the native speakers one. To this extent, to the increasingly well represented in the international journals, we found that the expanded participation, and particularly from the scholars from the global south, is not being translated into changing Anglophone rhetorical and linguistic norms, which means that there are some moment or some judgment that make it less normative to have non-Anglophone rhetoric. So this proportion gives rise for us to relevant question of how researchers from non-Anglophone countries, especially Indonesia, adapt these conventions to preserve the scholarly voice and identity. And that is why we develop a corpus, Praya corpus, we name it that, under the name that publication in research articles by Indonesian authors. And we will describe how the process of our corpus development. And the significance of developing this corpus is that it can be a tool to inform English as an academic purposes instruction for not only Indonesian higher education practitioners or early career academia, but also for the international English speakers when they are plugged by unconscious bias during peer review, where linguistic differences may misread as shortcomings. So as a corpus like Raya can detect common rhetorical characteristics or context-sensitive support, then it may have better information for the authenticity of different academic writing approaches. So here is the method. We collected 114 research articles from Indonesian authors' publication concerning in English language teaching topics. So we did bibliometric study, and we downloaded that there are 744 research articles authored by Indonesian researchers published between 2018 until 2030. However, there are some inclusion and exclusion criteria. Then we found that there were only some of the research articles, which means that it is only 114 that are that meet the requirement of the inclusion and exclusion criteria. We got 821,000 tokens collected from the top 10 frequent journals that accommodate Indonesian ELT researchers to publish their research results. So we found that the journals that accommodate this publication are still in the average impact factors. However, the journals have been indexed in a reputable indexing, which is Scopus. So here are the steps that we did to develop the corpus. The first one is corpus components encoding, and then the data omission, and the intercoder and manual annotation. And the last one is the reliability test by using Voyant and Sketch Engine. So the first one is in the term of corpus component encoding. Since I've previously mentioned to you before that there are some journals, the top 10 one that accommodate Indonesian scholars through their publications. And among these journals, the publishers are from Indonesian universities or Asian universities. So the authors may have their local language as their first language. So that is why we really pay attention that the papers should undergo professional services such as proofreading and reviewing. And then after that, the corpus files were processed at my university in Universitas Islam Indonesia under the direction of the first author. And when I put it in a PDF formats, were converted to a uniform XML format with attention to the spelling and character encoding. We cannot directly use all the characters in the text because some of them are not relevant to the corpus or computational linguistics trial. As a XML corpus, Praya is ready and then to be converted to other text formats. As I mentioned before that to have the inclusion criteria, we should really pay attention that the authors should really from Indonesia. So suppose that the articles were written by Indonesia and the combination of Indonesian and non-Indonesian scholars, so we will exclude this paper. That is why the reduction from the whole data, 744 to 114 files, it is a lot because we manually checking the author's first language. And then this is the data omission. We did gradually for the data omission. In the first year stage, our goal is that to collect the data, raw data, describe the metadata and reliability test, to three corpus analysis by using Voyant, Sketch Engine, and we have actually another one is Encon, but Voyant and Sketch Engine is more accommodative to show the annotation of the prior corpus. And then it is still closed access in the first year development. In the second year, which is this year, the prior corpus is expected to be open access, and it will be open access by the one of the platforms in these logos. And then we decided to omit the first one is the bibliographic references, and then the article dates, and long stretches of foreign text, and the author information. We put this in author information, and then article dates and long stretches of foreign text in the metadata, but not including in the corpus itself. The omission is conducted to ease the users of the corpus when they use concordance features. If we do not clean or omit the data, as mentioned in bibliographic and etc., then the concordance will not be clear. And this is the intercoder and manual annotation. So we put the title, and then we put the raw data in XML, and we have some intercoder from separate annotators, and then they put this annotation to which framework, to which coding framework in English language teaching does the sentence belong. And then the intercoder reliability was quantified with a Likert scale of 5. And then the scale is used as an agreement on the labels that were applied, negotiated, and refined. This is the longest process after we did the data omission. And then this is the reliability test that we did in Voyant. This is to show that how is the topic of English language teaching research conducted by Indonesian authors. And it was found that there are teachers, students learning language and English. So the center of research upon ELT by Indonesian scholars in Scopus Index articles are about teachers and students. And then as for the reliability in Sketch Engine, I would like to show it live. Hold on. So here I have the Sketch Engine, and I have put the prior corpus here. So for example, I would like to know what are the adjectives used by Indonesian authors. So we put it here, and then as the computational linguistics theory, we use 10 as the minimum frequency to look for the top words or word list. And this is the sample. And for example, I use the word English, and then I would like to find the concordance. And this is what I mean by it is necessary to have Sketch Engine here, because it is depicted in this annotation, the grammatical annotation. So for example, the word the is a determiner, and then influencing as gerund, and factors is a noun, on is an intransitive, and students itself is also a noun. So this computational linguistics is also helpful for the users when they try to look for how to use certain words aside from looking at in the dictionary. So okay, so this is the, hold on. Okay, so this is actually the results that Indonesian scholars in the prior corpus actually show mimic version of Anglophone rhetorics, but they can also have some uniqueness. In this case is that they love to use intensifiers like very and more to emphasize some adjectives. So like very good and very well in the articles. Regardless the uniqueness, their articles are still indexed in reputable journals. As a conclusion, the corpus marks both the stem of Indonesian academic conventions and Indonesian academics negotiation with Anglophone publishing conventions. So it is not like a challenge to the Anglophone or monolingualism, but it is a win-win on how each of international speakers of English can accommodate each other contextual or socially contextual Englishes that may happen when the authors write an article. And these findings also show that the need of more pluralistic and inclusive approach to scholarly communication, because English itself is an academic lingua franca. So I think that's all. We would like to thank for the sponsors of our projects, and thank you very much.
Great presentation. So what patterns or differences have you observed so far between Indonesian ELT scholarship and global North publications?
Yes, I did a corpus reference from the British Academic Written English Corpus developed by Warwick University, that the tone of delivering adjectives, for example, they used to have the native one or the Anglophone English, they used to have the adjectives directly. While in Indonesian scholars, they love to have intensifiers to strengthen and emphasize the findings, such as very good or very excellent. Yeah, I think that's one of the findings.
All right. And how are you kind of envisioning the corpus supporting Indonesian educators and researchers in developing strong academic writing skills?
Yeah, I have tried the corpus as a trial to my students, and they perceive corpus as a more authentic dictionary, because in the dictionary they sometimes cannot literally find the contextual use of English, but for the prior corpus they understand it much better because they can relate to their context and the social culture that they face during their talk in English.
All right, great, thanks.
Okay.
Thank you for the presentation. Now, we just have one more presenter left for the session. She was actually absent in the previous session, so we are taking the presentation now. And I'd like to call Anna Ortiz Vinen with the paper titled Plastic Waste Incorporated into Vehicular Paving Blocks.
Welcome, everybody. My name is Ana Ortiz Viñan from the Department of Civil Engineer at UTPL in Loja, Ecuador. I'm so grateful to be here in this conference. So let's get started. The title of the investigation is Plastic Waste Incorporated into Vehicular Paving Blocks. The contents: introduction, objective, methodology, results, and conclusions. Good. Over the past decades, plastic production and their use have risen sharply, making it the most widely manufactured material in recent history. Today, global output reaches around 450 million tons each year, and it's estimated that more than 9.2 billion metric tons have been produced in total. Approximately about 75% of this plastic has entered are polluting in the environment. In Ecuador, plastic consumption is significant, particularly to containers, bottles, and bags that are currently discarded. Research showed that recycled PET has a carbon footprint on only 0.45 kilograms of CO2 per kilogram. Reuse and recycling are considered important strategies to reduce the environmental and health risks linked to plastic waste. Consequently, using PET as a construction material emerges as a promising and sustainable alternative. Also, PET is recycled worldwide. Much of is still and been discarded. Reusing these waste in essential as it supports recycling and conserves energy during production. In the construction sector, the demand for natural aggregates continues to grow, since make are more than half or concrete volume. Substituting part of these aggregates with PET particles not only helps reduce pollution, but also promotes economic innovation in the industry. Previous studies show that increasing PET content in paving blocks lower compressive strength, but still offset promising results. Bidding on these nails, our study focuses on analyzing the performance of paving blocks for road surfaces when sand is partially replaced by PET plastic particles. The main objective of this study was evaluating the application of PET as a substitution for natural aggregate in the production of concrete blocks intended for the wearing course of medium traffic roads. According to Ines Stern, this application required a compressive strength of 40 MPa. The methodology was experimental. We did laboratory tests to characterize the materials, the mid-scene flows AC2011 method. It replaced fine aggregate with PET particles of 2 to 4 millimeters in three proportions, 5%, 10%, and 13%. Then we manufactured the paving blocks and tested their performance. The picture show the process. Results. The dimension of the PET particles used in the research are similar to those on the study by Mustafa et al. 2019 group. PET also use a sand replacement. Similar, Berhomat at 2020 applied PET with dimension up to 3 millimeters as sand substitute in their investigation. From the characterization test, use determined that neither the aggregates nor the PET exhibited organic impurities. The paving blocks were designed for a compressive strength of 40 MPa, and after 28 days, both the control blocks and those with PET substitution existed discharged. The best performance among the modified mix was obtained with 5% PET, showing only 3.382%. Regardless, compared to the control, this conforms that of all mix 6. Even with the percent and 30% PET, maintaining the strength above the Reweiger 40 MP8. All paving blocks meet the INEN 30-40 standard with water absorption below the 6% limit. Conventional blocks had 1.52 absorption, while blocks with PET showed 1.22%. Similar study indicate that in tracking PET can reduce homogeneity, causing harder porosity and potentially increasing absorption. Based on the obtained results, the fabrication of paving blocks incorporating PET as part of their composition constitutes a valid application. We crown with Islam et al. 2022 that the use of PET modified concrete as alternative to conventional concrete. Lizar-Saburo et al. 2023, it can be affirmed similar to Saxenda et al. 2018 that the use of PET waste as a substitute for aggregates in concrete can be employed in pavement and paving blocks. In conclusion, PET can be incorporated successfully as a partial substitute of fine aggregate in paving blocks. A replacement level between 5 and 13% achieved the required mechanical and physical properties. This approach not only provides a sustainable solution for plastic waste, but also reduce natural aggregate exploitation, helping to protect the environment. Therefore, we made this research observe a practical and innovative alternative for road constructors. Reference. Thank you very much for your attention. We hope this research that can contribute to sustainable construction practices in Ecuador and around the world.
Thanks for the presentation. So do you foresee scalability issues or economic challenges implementing PET substituted concrete blocks on road constructions on maybe a larger scale in Ecuador?
Laboratory tests show that the compressive strength is similar to that of traditional paving blocks, with the added benefit greater flexibility and crash resistance. By recycling plastic, we reduce the amount of waste in large files. Additionally, by replacing natural aggregates, the carbon footprint of the concrete production process in this grids. It is economically viable. The cost of the recycled raw materials is low, which make the final price of the paving block competitive in the market.
All right.
Thank you for the presentation. And with that, we have concluded the session and we are done with all the presentations for this session. And I sincerely thank all our authors for their presentation and contribution in this session and all our participants for being a part of this international conference. I hope this session was informative enough for you all. We, on behalf of the whole team, we thank you for your support during this 9th version and all the previous 8 versions of the conference. We'll be happy to have you in the 10th version in 2026. All the presenters will be getting their digital certificates within 2 working days. The publication will be live within 7 to 8 months. So kindly cooperate with the team of WS4 2025. I would also like to thank our session chairs for chairing this session. And here's a small token of appreciation on behalf of the team of WS4 and Global Knowledge Research Foundation and partners. So thank you so much, Ms. Shreya, ma'am.
Thanks,
And
Anisha.
yeah. Just give me a second.
Thank you, ma'am.
Professor Tanubia Chaudhary, thank you for your valuable presence, sir. And now I'll just request you all to please switch on your cameras for a quick snapshot. Okay, thank you so much, everyone. Thank you. See you all soon. Yeah.
Thank you. Bye.
Thank you. Thank you, bye.